Well, good evening, everyone. Thank you for coming to this of the first of 3 town halls that we are going to have at the Museum of Science on artificial intelligence under the general title Empowered by AI, and today is on the future of intelligence. I'm Tim Ritchie, the president of the Museum of Science, and I'm so glad you've taken some time to come here. Welcome to everyone online. The museum's role as a convener in this community and really to the world is important. The future will be driven by science and technology. We know that. The question is, what kind of world do we want? And that conversation is one that the general public cannot exclude itself from. Science should not just be what the scientists do. We can't step back from that, or else we will get a world perhaps that someone else wants. So as we engage in this conversation today about AI, and in the future here in other domains like life sciences, like climate change, tech and engineering, earth and space, and so many more, the museum's role as a convener is a powerful place where the general public, academia, industry, and government can come to talk about this kind of world we want. Well, if you want to make sense of big ideas like artificial intelligence, you can have no better host than Kara Miller, who will be hosting us tonight. Globe columnist now, but for 15 years also was the head of the creator of the Innovation Hub on WGBH, carried by 100 stations around the world. And Kara is going to help curate this conversation as we think through this big issue about empowered by AI, the future of intelligence. So Kara, over to you.
Tim, thank you so much for that really generous introduction. And thank you very much for coming out, for also for watching online. I think what we hope to do today is to shed some light on some areas and some aspects of AI that either you haven't thought about before, or maybe you haven't thought about in the way that we're going to talk about them tonight. And I think what's really fun and great about this panel is there's a huge diversity of experience and knowledge here. So we're going to come at AI from a bunch of different ways, both in terms of thinking about the classic things that you might think about, like where it's going, but also where it's not working that well, where it's being applied in ways that it's working incredibly well. And then we're going to turn AI kind of back on us and think about how are we using AI to understand who we are, why our brains work the way they do. And so, there's kind of this looking out at AI, and then what is AI telling us about ourselves as we kind of look back in the mirror. You probably have been reading the amazing biographies of the panel, so I'll just give the one sentence biography so I don't take the whole hour. Nancy Kanwisher is the Walter Rosenbluth Professor of Cognitive Neuroscience in the Department of Brain and Cognitive Sciences at MIT. She's a founding member of the McGovern Institute. Vilas Dar is president of the Patrick J. McGovern Foundation, which focuses on AI and on data. And Sarah Bargal is a research assistant professor of computer science at Boston University. Thanks so much to all of you for coming.
Thank you.
So Sarah, I'm just gonna start with kind of a question that we were talking about this a little bit before. People often use artificial intelligence and machine learning as these interchangeable things. So I thought, let's get right out of the gate and do definitions. So when I'm at my next, I don't know, cocktail party, brunch, whatever, and somebody just throws around machine learning as if it's AI, what should I tell them to say, actually, here are the differences?
Yeah, wonderful. So AI is any algorithm that tries to mimic human intelligence. However, machine learning is a specific AI algorithm that does so in a way that utilizes data. So we could have AI algorithms that do not use data. So if we use our favorite maps application on our phone and say we'd like to go from point A to point B, that could easily be solved using an AI algorithm that does not require any use of data. However, if I do ask my maps algorithm that I'd like to go from point A to point B, but I'd like to go there with the least traffic, and I'd like to pass by the Starbucks that has the highest rating, or your favorite coffee place, and that would require a lot of user data in order to be able to give you such recommendations. And so such AI algorithms are machine learning algorithms. So the main difference or a deal breaker, I'd say, is whether we need data in order to be able to solve the problem, or whether we could use an algorithm without the need for any data at all.
Do you feel like people throw around those terms just all the time in random ways?
Yes.
Does it annoy you?
Particularly in the news. So there's a lot of, they're used quite interchangeably, and sometimes it's pretty clear that you know, the use of the term is a little out of context, but yeah, the big thing is data, whether we use data to train these algorithms or not.
And then I'm gonna stick with you for one more question, which is, if you can just take people through a day, either a day in your life or a day, you know, in an average person's life, where do you think we're encountering AI, both in ways that we might be aware that we are and in ways that we're really not aware that we are?
Yeah, so if you surf the news in the morning, you're likely to be using AI. It's recommending specific news from specific perspectives for us to read and engage in and, you know, enjoy sometimes. If we're using our, so I gave the example on maps, if we're using our phones, where teenagers now like to play a lot with different applications, social media applications or styling applications. And so being able to use an app where you would style your photo in a specific way, as if Van Gogh has painted your photo, for example, is an example of an AI algorithm that could have used data in different paintings and therefore would be particularly a machine learning algorithm. Various programs in healthcare also use AI. So as the technology is, you know, becoming everywhere, integrated into a lot of crucial applications, it's also growing such that we, in the medical field, for example, they're able to have CT scans that have more slices than they did previously. And so radiologists may not have, you know, the time to look at every single one of these thousands of slices, right? And so having a machine learning algorithm be able to point out particular regions in these slices to get, you know, more attention would be, you know, great. And this is currently work that is underway, for example. So healthcare applications, autonomous vehicles, for instance, are examples of also other technology that may not be, you know, on our phone right now, but it's technology that's underway in many different companies.
So I'm gonna ask you, if you have your phone, to go to slido.com to enter this code, MOSAI, because we're going to do throughout the hour a couple little things with you that are interactive that you're going to vote on. And then at the end, or anytime, you can also submit questions that the panelists can answer at the end. So if you can do that, we have the first thing. I'm going to show you two clips of a poem. One is by Walt Whitman, and one is inspired by Walt Whitman, but created by a Google program called Verse by Verse. So if you want to take a minute before you maybe even enter your answer, turn to the person next to you and see what you think. Do you agree on what is it, number one or number two? What is the real Whitman poem? What is the, you know, AI generated poem? They don't know this either, so they're gonna just take a look. I'll get out of the way.
No cheating by Googling it.
Yeah. Let's see if I can.
There is no Wi-Fi
No,
I don't know. Is
I
there
didn't
one?
need one. You just accept or whatever.
And then, so when you're done talking about with your neighbor, enter your vote. Susan is tabulating. She says they're still coming in. Do you guys have thoughts up here? I know you're not voting.
It's,
Yeah.
it's for
Were
sure.
there any
It's just for
strong feelings? All right, let's see.
Yeah, I think one is
Okay.
AI.
It sounds like most people are saying number one is Whitman. You said you thought number one was the AI.
Me too. Yeah.
Number one is AI, yeah. Number two is Whitman. It's from a poem that he wrote. It's just a few lines from a poem he wrote called Crossing Brooklyn Ferry. So, Nancy, I'll ask you since you're our brain person, and clearly our brains and AI are getting a little bit crossed. What do you think when you see this and you see the analysis that's going on out here?
Well, first of all, it's pretty amazing how hard it is to tell, isn't it? And I'm not an AI expert myself. I use it a bit in my research. I'll tell you about that in a little bit. But what I did was I looked and I thought, well, one of the things that seemed funny to me in the first one is the syntax seemed a little bit off in a kind of not human kind of way in the first line. In need of a bigger boat, brought the old drunkard to his side. You know, it's like it could be a poem, but I just thought a person wouldn't write that. So I wasn't really using any deep understanding of AI. I was just thinking that does not sound like a person would write it. So.
It is, you know, if you try this on Verse by Verse, which is this Google program, you will see that you have the ability. I'm trying to think when I did this, if I threw out different lines, you can say, like, I don't like that as a second line. You know, it doesn't make any sense, really, and you can throw it out and keep iterating until you get something that feels like maybe it works together as something cohesive. Let's go to the next slide because, Nancy, let's talk a little bit about where AI is getting things like pretty good and where it's, you know, there are some maybe gaps or underperformance.
Yeah, so this is from a image captioning AI system from a few years ago where, I can't quite see it from here, but you serve up that picture and you ask it to give you a caption, and it says, a dinosaur on top of a surfboard. Like, oh, that's pretty cool. Especially since the AI program has not probably seen a dinosaur on top of a surfboard before. So if we do the next one, I don't know who's controlling it. You know, a group of people on a field playing football. Pretty good. Next.
So you give them the picture, they tell you what it
Yeah,
is.
yeah, you give it to the AI program and it has to come up with a caption. Here it says, a group of people standing on top of a boat. Close, but not right. Next one, this is my favorite, a necklace made of bananas. Whoa! So I think these are fascinating and revealing. They're really good at some things, but the particular patterns of errors are very diagnostic, particularly the people on top of a boat. I think one of the things that AI people talk about is the idea of compositionality. That is that we have these pieces that you can understand, but understanding how to put them together in a sensible way and what that new construction from that new assemblage means is a hard thing. And you see that with the people standing on top of the boat. Not.
Vilas, you think about ways that AI can be applied in places that I think people are familiar with the fact that, you know, Google and Amazon and Netflix and all these companies, you know, are using AI, you know a lot about us. But you think about the world of nonprofits, which is a place that AI has been used in some really useful ways. Talk a little bit about that and what things people may not expect.
Sure. So, look, I'm an optimist, right? And as much as I'm concerned about all the bad things that AI might one day do, I want us to focus on the good things that AI is letting us do today, right now. Sarah, you spoke to so many of the ways that we're seeing AI intersecting with our lives, but I could extend that list maybe to the world of social change, where AI is helping farmers in subsistence environments figure out when to best plant their crops so that they can receive the most significant yield. We're learning how to use AI to do things like, in a world where we don't have as many vaccines as we need, how can we see what people are saying on social media to see if we can really target where the biggest need is for a particular disease outbreak and get vaccines there before they're actually needed? So in many ways for me, like AI isn't really a future, right? We sometimes fall into that trap of talking about like, what is AI gonna look like in our future? AI is just a tool. And as we've seen on these slides, AI is deeply imperfect. But what AI should be about is how do we help people make better decisions? And in my best version of the world, how do we help people make better decisions about how to be good people? So I could give you 20 more examples like that, but at the end of the day, I think of AI as a really powerful tool, and the people that should be using it are the ones that are trying to do important things that make the world better. And we need to figure out how to get the tools closer to those people.
Do you want to let's drill down on maybe one of those examples. Do you want to talk a little bit about AI and climate and ways that AI is being applied or that you see it being applied in the next few years in terms of how you think about climate and its effect on people? And
Absolutely. I mean, look, and I think you just said it in the last few words there, climate is all about people. But in order to understand how the changing patterns in the world around us are affecting people, we need to start from data. And we spent a lot of time over the last couple of decades figuring out how to build those data sets. We put up satellites that monitor methane and carbon dioxide emissions. We've looked at what's happening to broad swaths of rainforest across the Amazon. But now we need to do something with all of that data. And this is where AI really begins to play a key role. Is there so much data out there that if you asked a single decision maker, where should we invest in more people capacity? Where should we first direct our attempts to constrain methane? We'd be a little bit of a loss. We could probably make a good guess, but humans aren't capable of taking those millions of pieces of data and doing something with it. So two really great examples of what's happening. The first is taking these very large data sets and making them accessible in useful ways to people who are at the front lines. I think about people who are working the Amazon today to fight poachers and loggers, people who are going in and illegally deforesting millions of acres. Well, what we can do is we can take all of this data that comes off of satellites, that comes off of methane readings, and turn that into really easy to use apps that people can have on their phones that say, hey, I need to figure out where I need to be today to most effectively defend against poaching. And that's a set of tools that have been built by Digital Democracy that allow you and everybody in this room can actually go and download them and get really great real-time maps that show where the effects of climate are most devastating and how we can intervene. A second very quick example is to think about how our individual kind of experiences and observations have to inform policy around climate. And in a pretty great and amazing organization that also has a presence right here at the Museum of Science, a group called I See Change has built a tool that let each one of us, on days when it's particularly rainy and we see a street block up, when floods happen because the tides are very high and we see that entire neighborhoods are going underwater, where we can actually just go in and drop in our observations. We can become data creators that then feed into an algorithm that then informs a city planner to say, as they're trying to figure out where they should go and build a higher seawall, or where they should go and make sure that the drainage system is particularly good. They can use AI to look at that data we're all creating to go in and make a very clear short-term decision.
Sarah, I'm guessing that people who are at this event generally think, may think that AI has a lot of potential. But I just want to address, I think there's also often a fear of AI, that AI categorizes people in ways that they shouldn't be categorized, or they, sort of separates, it's a force for separating people from other people, maybe in unfair ways. I'm sure you've heard those kinds of questions. How do you think about them? How do you process them? What do you say?
Yeah, so we teach these methods how to learn. And by doing so, we can get a lot of great applications, but at the same time, it is very easy to have these methods inherit the bias that we have. So if we use data to train these machine learning algorithms, and our data is biased in some sense, then it's very easy for these algorithms to inherit this bias. And what we would like, since we're training these algorithms, we would like to, we'd like to have these models perform better than we do, right? Or at least, not to inherit these biases and so on. There are many different, research studies on how to do so. How can we, first identify what the biases are that we care about, and how we can mitigate such biases, and to what extent can we mitigate these biases. Yeah.
So let's talk a little bit about something that I know your lab is working on, and then Nancy's also going to chime in on the issue of vision. But AI, you talked about medical slides before and detecting cancer, and if you're looking at, maybe a person can look at 100, but can they look at 10,000? Well, probably not, especially if they're trying to look at a bunch of patients. So vision important in medicine, obviously vision important in driving, Yeah. So talk a little bit about where vision with AI is, and like what some of the limits and difficulties are.
Yeah, computer vision is one of the really cool applications, I would say, for AI, mainly because we can very, naturally interpret images and videos, and so it becomes very exciting to see how models interpret them as well, and how we can, give feedback to improve these systems. And so if we assume that, we're designing a vision system for some autonomous vehicle, one thing we would like this vehicle to be able to do is to be able to predict if there is a pedestrian crossing the road in front of that vehicle, right? And take appropriate action. And so if we were able to train such a system to achieve a super high accuracy, like a 99.9% accuracy, the question becomes, is this sufficient? Shall we deploy this system, right? And we argue that, it's not sufficient, and we should not deploy the system unless we really know why it's doing very well. So this example on the slide here is showing on the left-hand side some pedestrians crossing the road. And let's assume that that vision system is able to get this very high accuracy because it's modeling the periodic motion of the legs of the pedestrians as they, cross. Now, if that was the case, and then the pedestrians looked like the image on the right, where their legs are completely occluded, right, then we obviously have a problem. And it might very well be that we had strollers in the training data set, but it may have just not happened that, every single one of the pedestrians had a stroller, and therefore all the legs were completely occluded. And so it's very important to identify why a system is performing very well. State-of-the-art algorithms at the moment are actually algorithms that are not very explainable. And so a lot of work needs to go into identifying why they make specific predictions, map this to evidence in the input, such that we're able to come up with conclusions as to such systems are, whether they're ready to be deployed or not. If this autonomous vehicle gets into an accident, whose mistake is it? And who should be held liable, right? So all of these are questions to be worked out, not just by computer scientists, but by policymakers and other interdisciplinary researchers, I believe.
Okay, so let's go to the next slide. You can vote on this. You can just enter what the activity is shown here. This is kindly provided by Sarah.
One of my favorite examples. So this is a video frame from a video. It's a data set on action recognition that researchers use to teach machines. So I give the machine videos, and I train the machine to identify actions happening in videos. And so this is one frame of one of the videos, and you should now be guessing what the AI module decided the baby was doing. The ground truth label is baby crawling, obviously, but the AI model that I trained had a different opinion. So we'll see if anybody
It looks
gets
like
that.
somebody already did get it.
Okay.
Susan, did a bunch of people get it right?
Most people said crawling.
Okay, most people said crawling. Yeah.
Yeah. So the model I trained said push-ups. And now, yeah, obviously,
Kind of.
yeah, the pose of the baby is very similar to the pose of a person performing push-ups. And so, it became really intriguing, and we wanted to know exactly why the AI algorithm, decided to say that push-ups is happening there, but obviously it doesn't have this, semantic information that babies don't typically do push-ups. But yeah.
The best answer, the person should probably get an award, is planting flowers. Isn't that a good answer? So let's go to the next slide if we can. And I just want to talk quickly about some work that you're doing in your lab, with vision. And one of the big problems in thinking about, Vas was talking about the environment, and thinking about the environment is that most of the recyclable material in the US is actually thrown away for a number of reasons, but part of the reason is it's very hard to sort things. People are pretty good at it, but there aren't a ton of people working on sorting recycling. And so what are you working on, and how hard a problem is this to solve?
Yeah, so there aren't a lot of people to work on all the recycling materials that we have, but also it is not it's a job that is difficult and has dangers for humans and contamination and so on. And so we would ideally like to be able to automate some of this. For example, if we had some vision system that was able to locate all the plastic items, and then we would have robotic arms being able to pick up these items, that would be really great for the environment and for individuals who could be reskilled to do other jobs that would not pose such challenges. So in this image that is up, the goal there is basically to identify the boundaries of specific objects and actually say what each object is, where it is, such that we would be designing robotic arms that are able to pick up these particular objects and dispose them in the correct places.
And if we go to the next slide, Nancy, you can talk a little bit maybe about how your lab has looked at the issue of vision and where there's kind of a crossover between the way computers think and the way people think.
Yeah, so my lab is using a lot of these tools now to help us understand the brain. And the background is that in my department at MIT, a lot of people have been doing this for a bunch of years. And frankly, I don't have a background in computer science, and I was sort of hiding in a corner hoping it would all blow over. So it's just going to be a flash in the pan. I'll wait till it goes by so I don't have to learn this stuff. And then a few years I started to realize that actually this is pretty empowering. And so now, like, half of my lab is training deep neural networks, go figure. But it's fascinating in a bunch of ways. And one way to see this is that up until about 10 years ago, we did not have computational models for how visual object recognition works. So any of you, if I had a series of slides of random objects, I could flash them up at almost 10 per second, and you would just recognize each object no problem, even in a completely random sequence of images. So we do that because we have a lot of brain back here allocated to that task. But me and lots of other people have been trying to understand how do those parts of the brain solve that problem. Until around 10 years ago, we didn't even have a single machine model of how object recognition might work. And then one of the big advances of deep learning was the development of convolutional neural networks trained on huge numbers of images that are suddenly incredibly good, not quite at human level, but almost at human level in object recognition. And this is big, big news for us because now we have at least one computational model that can do the job. It doesn't mean it's how the brain does it, but it's the first time we've even had a viable hypothesis to test. So that's exciting. And even more exciting is that lots of people in my lab and a bunch of other labs before us have been looking at the activity in the brain in humans and monkeys when they recognize objects and finding out that actually the pattern of response in your brain when you look at an object has a lot of similarities to the pattern of response in a deep neural network trained at object recognition. And that so didn't have to be. You know, I mean, this thing is just some machine trained on images, millions of images, and this is a very, very different kind of machine trained on, you know, millions of years of evolution and, you know, my lifetime. And why should those two things come up with a similar solution? But it seems that they do. So that's big news, and then we can use it in all kinds of ways to, we can now predict the response of neurons and batches of neurons in parts of the human brain with incredible accuracy, using these models. And my favorite thing that we've done is one of my lab focuses on parts of the human brain that do very, very specialized things, like face recognition, or understanding a sentence, or thinking about what another person is thinking. Yes, there's a special patch of the brain that does just that. And so I'm interested in why that is a good way to design a brain. Why should a brain have specialized machinery for particular tasks rather than just generic machinery that can solve any old task? And so we took the case of face recognition, and we trained a neural network on both face recognition and object recognition. And it did really well at both. And I thought, wow, well, okay, this is one thing that's doing both things. That's not how it works in the brain, and so that wasn't what I predicted. And then we thought, oh, let's look inside. And the network had spontaneously segregated itself into two separate processing pathways, one for faces and one for objects. And to me, that's just the coolest thing ever, because it says, like, the reason the brains do this is probably because that's just what an optimized solution looks like. These are two different problems, and the network figures that out, and evolution and learning in the brain has also figured it out. So it's just empowering neuroscience in heaps of different ways, and it's pretty fun.
Vilas, if you had to look 5 years in the future, and I feel like 10 is 100 in this field, so 10 I won't even venture to ask. Are there ways that are surprising you, that would surprise us, in ways in which you see AI being used going forward? I mean, I feel like you talk to different organizations all the time. You hear what their plans are. What do you see ahead?
Yeah, I love that question. I love talking about this. Let me take you back. I think the last 20 years have been about humans getting better at the things that we do, right? So I think about something like email. Email took us out of having to write letters and gave us a more efficient way to communicate. Now we all email each other. Now we're texting and Snapchatting and everything else, right? But it's kind of a linear progression. AI is not like that. You know, 5 years ago, what did we do with AI? Well, maybe folks like the people sitting up here spent a lot of time writing lines of code and banging our heads against a computer because it wasn't working. Today, AI is already everywhere, and it's changing the way we interact with each other. You look at things like the creation of artworks, right? The poetry that you put up. For the first time, we've gone from being faster at doing things we were already doing to saying there's a tool that lets us do something really different. To take our innate creativity and build something that the world's never seen before because a tool helped us get there. 5 years from now, I think AI will be deeply pervasive in everything we do. But it's also going to get more and more alien. It's going to get weird, everybody. I think about Nancy's example here, like where AI is already starting to, without us trying to do so, build pathways that look a lot like our brain. If we're really able to take that and do something cool with it, what would it look like for humans to provide the problems and the creativity, for AI to provide the horsepower, and for those two things to come together in ways that let us build new kinds of artwork? I think about video games as a great example, right? Because so many probably in this room that play video games. Today, you sit down to play a video game, you're playing a video game that somebody sat down and wrote and drew and created for you. But using GPT-3 or some of the new AI-driven language tools, what would it look like to go into a game where there was no plot line, there were no rules? What you did meant the system would respond to you. One person might go into that game and decide they wanted to learn math or science or physics. Somebody else might say, I actually want to spend my time in this game writing a romance novel. Somebody else might go in and say, what I really want to do is bring together a set of people, real and virtual, to have a conversation about a question in philosophy. This whole world, and you just said it, isn't 100 years away. I don't even think it's 10 years away. It's 5 years away. And the question that I always ask is, who's making decisions about what kind of tools we're going to build? Are we going to focus all of our human energy on building better marketing tools that make you buy the next thing on an online retail store? That's where a lot of the private sector is working. But institutions like I think the ones that both of you represent, that this museum represents, civil society, we have to come together to say, let's build really cool tools that let us do really cool things together.
You and I talked about a story I had reported on years ago where Child Protective Services around Pittsburgh had put out a call to say, can we essentially crunch the data and try to predict who needs help, because we can't send help out to everybody. And these are tricky questions because there are biases built into the algorithm, but there are also biases built into all the people, right? Who are the alternative in some ways to the algorithm. How do you, I asked Sarah a version of this question, but that kind of controversy where you see wow, there's this huge data set and there's all this data about all these people, and how can we possibly know, how can we possibly distill these thousands of points of data about all these different people into something that will tell us, well, visit this person, but this person's going to be okay. How do you think about that?
I think the question you're asking is the most important one, and I think about it in the context of trust. Who and what do we trust? I'm not a person that will ever trust a machine. I won't trust the results of an algorithm that tells us, go here and do something, tells a judge, this is how you should sentence a criminal, tells a car, this is what you do. Instead, I want to trust human decision making, right? The ways that we built a society together for the last thousands of years, right? Built ethics and representative democracy. These tools will always be just that, and we have to be really careful. It's so easy to think of AI and say, I've seen The Terminator, or I've seen these new movies, and AI will do everything for us. No, the answer is humans still have to make the important decisions, and we have to learn how to use AI to help us make them better. There are going to be lots of problems along the way, and we're seeing them now, right? Where AI has results that are racially biased, that bring in gender bias into the workplace, that create all kinds of challenges. But I have trust that if we come together and solve those problems the same way that humanity has always solved them, at least we have a path forward.
Nancy, one last thing I want to talk about before we go to questions is just have you expand a little bit more. I talked at the beginning about, AI being turned back on us. We call it artificial intelligence, but then how much can it really help us understand who we are, what's inside here, what our intelligence looks like? Do you want to talk a little bit about some of the work you do?
Sure. So I mentioned some of this before. So this is a diagram that of some of the work in my lab where we've discovered we and lots of people in the field have discovered parts of the brain that do very, very specialized things. And so, as I mentioned before, some of those regions, the ones that are involved in recognizing objects and faces and scenes, we can actually model their responses with these deep learning networks that have been trained on visual recognition. And we can do that so well that we can predict their responses to completely new images just with extraordinary accuracy. So that means we have a predictive explanation of what those regions are doing and a computational model of what they might actually be computing. And this is all new in the last few years, so that's super exciting. And then I also mentioned that we can use these methods to ask why systems work the way we do. Why does the brain have a specialized face processing system? Well, to the extent that we can train up a network on a wide swath of different stimuli, and it will also spontaneously create a face system, that's starting to tell us why the brain is the way it is from a computational point of view. But we can also use these things to discover the limits of these models. So these models are incredibly effective for vision, the kind of stuff that Sarah works on. Those vision models trained with deep learning match what the brain does really well. In more recent work, the large language models, the kind of models that produce the Walt Whitman poem, they're getting more and more amazing in their ability to generate human-like prose. And actually, you can use those language models to compare them to activity in the human brain. And just in the last few months, a couple of papers have come out, one from my colleague Ev Fedorenko in my department, another from another lab, showing that those large language models can account for what's going on in language parts of the human brain as well. So it's not just vision and hearing, it's really higher level human functions that these models are starting to capture pretty well, giving us computational accounts of these things. So that's awesome. But the final thing that I think we can really learn from these models is what they can't explain, right? And so, vision is not just getting a set of categories, person, chair, dog, toaster, pineapple, whatever. It's really understanding what's going on in the world in front of you, understanding the physical arrangement of things and the physics behind the situation in front of you, the social engagement. And so we can see the kind of thing that AI systems are not good at now, that I think these kinds of models are just not capturing. And if you look at that image, I don't know if it's big enough to tell, but the captioning label says, I think it's a group of people standing next to a man in a suit and a tie. How did I do? Well, you kind of missed the boat. And so channeling my colleague Josh Tenenbaum, what he would say about this is that the deep net models are very good at pattern classification, detecting the objects and features and things in the image. What they're not good at, but people are, is building models that enables us to understand the world. So if you look at that image, and you think about a couple of questions like, what do people here know that the guy on the scale does not know?
Do you want
Right.
to say, just in case people in the back, you want to say what's happening here?
Okay, what's happening here is that there's a bunch of people probably in the West Wing, I don't know, and this guy is standing on a scale. I think, is that Comey? I forget who it is. Anyway, he's standing on a scale, and Obama is coming up behind him and putting his foot on the scale. And everyone else is laughing. So to understand that, you need to know all of this stuff about the world. You know that people are sensitive about their weight, that this guy doesn't know that those guys are watching. That's part of what makes this scenario funny. And so what's useful about examples like this is it illustrates human intelligence, the kind of stuff that's just second nature to us, that the machine models are still really terrible at. So it's probably going to turn out that the kind of deep learning, convolutional neural networks, even the language models, are just not going to capture this kind of thing. And what we do in our heads, you might think of it as common sense, is have models of the basic physics and social structure of the world that enable us to understand things like that.
So submit your questions via Slido while you're doing that, because we're going to go to questions. One last quiz for you. In 2016, a Dutch advertising agency created a fake Rembrandt. So 3 of these are Rembrandts, and one of them is an AI Rembrandt. And it was fed all the Rembrandts that are out there and tried to figure out, how does Rembrandt draw and what kinds of people does he draw? And so 3 of them are real Rembrandts, and so you want to vote for the fake one. So we'll see how you do here. It's amazing, isn't it? I mean, they all look kind of the same. Okay, maybe 10 more seconds, then I'll let you know the winner.
The suspense.
Here's, which one do you think it is the fake? Oh, no, wait, I'm going to have you go last, because I feel like you're the AI expert. You might, Nancy, which one do you think it is? Do you know?
I looked at these, I have no idea. Honestly, I have no idea. They all capture the classic Rembrandt lighting thing that he's such a master of.
Wow. Vilas, do you have an idea?
I'm going to guess 2 is the fake.
Okay. And did you have a guess? Okay. It looks like 2 is in the lead as the fake with 40%, and all the rest are at 20%. The fake is 3.
Ah, well
Yeah.
done.
Nice.
Well done.
Yeah.
I know. AI is pretty good. That's today's takeaway. No, so I'm gonna throw some questions in from the audience. I'm just gonna ask these, and then whoever wants them can take them. Vilas, you actually touched on this a little bit. Why do you think AI is usually portrayed as evil and scary in the movies, and how can we change the perception?
I think we need to change the reality, right? That is, I think there is an actual risk of a lot of harms that could come from AI, in terms of, people losing jobs if society doesn't do the right thing and find alternate employment for people who are going to lose their jobs. That's a real risk. I think there's all kinds of risks, and these need to be handled with serious legislation to protect those harms. Yeah.
Well, a follow-up on, sorry, Vilas, did you want to say something?
No, please.
No, a follow-up on that, and we could easily do an hour on this sometime, but to what degree do you feel like as AI gets better, it will eliminate, large groups of jobs?
Yeah, so I think like any technology, like the internet, when it all started, right? It did eliminate a lot of jobs, but it did create, a larger number of jobs. And I think the basic idea there is for society to create, have set up for reskilling individuals who, lose their jobs such that they're able to fill in other jobs that are just generated by this new innovation technology.
I want to answer your first question,
Yeah.
and I want to just acknowledge it. I mean, AI is really quite a disconcerting thing. I'm a computer scientist, and I've spent most of my life thinking about this stuff, and if you ask me to explain how a particular algorithm works, it would take me a while to get there. How can we ask the average person who's not a computer scientist to talk about it? It's very unfamiliar, but it does something that is really powerful. It does something that we all think is something that only humans were ever able to do before. So now you've got a machine that can, what looks like reason. Let's be honest, they can't reason, but from a distance, it looks like they can reason. It looks like they can figure out things about the world. And we're scared, and we should be. And Nancy, I think you put it right. There are lots of challenges ahead. But the challenge in front of us isn't, how do we be scared of it and destroy it? It's how do we make sure that we use it to do what we want to have done? I think the same is true for jobs. And I think, Sarah, your point is exactly right. Yeah, we're going to lose a lot of jobs that are dangerous, right, that don't pay particularly well, that put people at risk, and machines are going to take those over. So what are we going to do instead? Well, let's do the human work, right? The creativity, the empathy, the social connections, the decision-making, the model creation that Nancy alluded to. Now that means we're going to have to work at it, right? We're going to have to retrain and reskill a lot of folks. But hopefully it leads to better economic welfare for everyone.
Somebody asked, could there be a point at which AI influences human decision-making, i.e. humans making decisions based on, data as opposed to human emotion, so that you kind of lose what makes us human?
Yeah, we're already there.
Yeah.
So on your favorite social media platform, you're being recommended, friends or industries to follow based on your interests that, happen to be similar to other individuals' interests, for example, right? And so it is really, influencing what you see, whether it's news, whether it's connections, whether it's perspective. And so I believe we're already there. There's also a lot of work, parallel work that is trying to do the opposite, to actually present you with the different views and the different sides of things. But it's there. There is, let me call it bias in how recommendations look like, the ones we see every day on our different applications that we use.
How do we address that bias? I mean, we talked a little bit about the idea of people being biased, right? We all are kind of familiar with that a bunch of people walk into a room and you might think different things about those people based on a whole set of characteristics. Who's good at math, who's not good, whatever it is. But how do you deal with the other issue that we've talked about so much, which is like our own biases, like, you know, that I like to read news stories that are like this versus like this, and then it keeps getting fed to me, and, you know, I start to live in a world of my own creation where everything sounds like something I want to hear.
Yeah, this is a great question. So in machine learning, there is one group of learning algorithms are called supervised learning algorithms, where you actually tell the algorithm, you know, this is the example, and that's the label we'd like to give to that example. And for this type of learning, it's, you know, it's possible for us to account for this bias. For example, we would like to show the system an equal number, right, of images for every one of the classes that it would like to classify into, for example. For other kinds of learning, such as unsupervised learning, it's not as easy. So think about social networks that have millions of nodes, right? So these millions of nodes, it's very difficult to have supervision. So how can I classify individuals, all the individuals on, Facebook or Instagram, into different types of people, right? I mean, how many different types of people are there? I don't know, right? No, I don't believe anybody knows. And so we resort to these unsupervised learning techniques, right? And these techniques learn structure more than learn or, assign labels. And most of these algorithms work with, similarities of different data items. So it would work on structure and say, these people seem to have similar interests than, to this other group, for example, as opposed to assign a label. And so it can be very difficult to get out of a social bubble, right? If you are already somewhat, in that bubble.
And we only have like 2 minutes, but I'd like each of you, Vilas, Nancy, to just think about, when you think about what we've talked about, what is the concern that rises to the top for you that you would like to see addressed?
I think the one I mentioned before is that we've talked about, it's just not leaving people behind. Like, absolutely, it's great to get rid of crappy jobs that people don't want to do. If they can be replaced by AI, great. But you can't just leave those people behind. And unfortunately, I think that's what governments have traditionally done. And so I think that's what will happen absent a really strong governmental effort to retrain people and not leave them in the dust.
And interestingly, it's like AI is the domino that falls, but you're saying like then the next thing that has to happen is like government has to be spurred to action because of AI.
Mm-hmm.
Yeah.
Can I be a little silly for a second?
Sure.
Sarah, as I was seeing your work about spotting trash versus recyclables, like what I was thinking about was going to an arcade. I'm pretty competitive. You know the claw machine? Like that thing where you have to pull the claw and grab the toy? And I was like, if I had an algorithm like what Sarah was talking about, and I had enough pair of glasses, I could beat every arcade claw machine out there. But I think it's an interesting example, right? Like the ways this is going to intersect with our lives, we don't even know. And all I want to ask for in the world is that we don't spend all of our combined time and money and creativity building really boring AI applications that make the world a worse place, a more unequal place, a more inequitable one. And so right now, we have to make a decision, now and in the next 5 years, to say we should put resources towards AI that actually makes the world better, and put those tools in the hands of people who are trying to do something good. And if we don't get that right, then we've got a whole lot of problems coming.
Thank you so much for your questions. There were a million. I feel like the hour went by in about 7 minutes. Nancy Kinwisher, Vilas Starr, Sarah Bargal, thank you so much. This was fantastic. Just the beginning. Thank you.
Thank you. Thank you all.
Thank you.
Thanks so much for coming.